We introduced the concept in Chapter 5 of estimating project times and cost. Estimation and getting a good handle on cost before a project gets started is important, and the level of effort and time you put into it depends greatly on the type of project that you're doing, where you're at in the project planning phase, and a variety of other considerations. But no matter what, it's a way to determine what's going to be expected in terms of resources and ultimately cost for the project. There are two types of estimates: these macro estimates that we use to initially determining some initial costs, and then micro estimates, which are used when we've drilled down to the work breakdown structure and we're looking at the individual tasks and what it would take to do that work. Here are some general guidelines you should use for estimating times, cost, and resources. You may want to check with others that are familiar with the task and have them make the estimates. If it's something that a few people know about, maybe you do a poll or ask a bunch of people what they think, and then from that make your best guess. When you're doing estimates, let's make sure that we're talking about estimates that are based on normal conditions, efficient methods, normal level of resources, and so then if we need to do things like bring more resources on or put people on overtime, we'll know that's above our baseline. We should also, when we're doing this, make sure we're using consistent time units. I know within the SIM project, the SIM itself is looking at everything in hours. And then when you go to your Microsoft project plan, everything's in days. That's how it's a bit of a challenge, I bet. We can change that within the SIM, or at least within your SIM project, Microsoft project output. You should keep tasks independent, don't aggregate them, so that you can actually drill down to the specific work package level. Don't make for allowances for contingencies within the estimating process. Contingency and contingent planning is part of your risk management plan, and we'll discuss this in Chapter 7. So when you're doing your normal costs, normal times, don't worry about that. And that leads to number 7. Having a risk assessment helps avoid surprises to all stakeholders on the project. So we'll talk about a risk assessment plan and a risk response plan that will address things like times and cost when we hit Chapter 7. As I said earlier, there are two types of estimating methods: top-down estimates and bottom-up estimates. In the top-down estimate approach, we're usually going from someone who has some experience or knows enough about the project so that they can give us a total duration and total cost. We'll use some of these techniques by top management to just get ballpark figures through a few of these estimating techniques so that we can get through our first go, no-go gate to see whether the project makes sense to do. The bottom-up approach can serve as a check on where you're at with your work breakdown structure, the individual tasks, and also give you a reality check to how close those top-down estimates relate to your bottom-up estimates that you came up with when you drill down to the lowest level work package. Assuming everything goes right and you can follow these preferred methods, here's really what you should do if you're looking at a new project to analyze. Come up with the best way to make a rough top-down estimate, whatever that might be, and we'll talk about a few ways we can address that in a second. Then, assuming that top-down estimate gets that first green light, develop a very specific work breakdown structure, figure out how that work will fit within the organization by overlaying it within your organizational structure. From that, we can do our bottom-up estimates, look at schedules and budgets, and then if we see a big gap between our bottom-up estimate and our original top-down estimate, we can have a discussion around the gaps and make sure we understand what's happening there and come to some resolution before proceeding with the project. Let's take a look at the top-down approaches for estimating project times and costs. There's a few methods the book describes: the consensus method, the ratio method, the apportionment method, function point methods for software and system projects, and learning curves. In the consensus method, we do just that. We talk to some of the people that have been around for a while, that have worked on some of the projects. Maybe you independently talk to a bunch of people that aren't talking to each other about this, and you get their best estimate for the work involved, and from the high and the low and the midpoint you come to some macro estimate that you can use to move forward. The ratio method's a little bit more concise, and you can envision that if you were going to build a building and the typical build costs in a metropolitan area are $200 per square foot, and you know you're building a 10,000 square foot office building, you kind of can zero in on the price of the building pretty quickly, at least from a rough estimate standpoint. Apportionment methods and function point methods I'm going to show in the next slides, and so I'll talk about those then. But just one last thing about learning curves. And if you're interested in learning curves, Chapter 5 Appendix does cover that in greater detail. But we've all experienced anything we've done multiple times. The first time through, it takes us a lot of time to do the work. And as we start repeating that task and doing that work again, we get better at it. And so the concept of learning curves, and the researchers have captured that in a systematic way, and so feel free to go through the Chapter 5 appendix to learn more about learning curves. But now let's move on to the apportion method and the function point method of estimating project times and costs. This is a good example of an apportionment method, and in this method we have a really good understanding of the project, and we have a good understanding of what the individual portions of the project take up. In this example, testing is 40% of the cost of the project, programming 30% of the cost, and so on down the line. And you can drill down to the lowest level of the work breakdown structure, which you're seeing here, and the portioned work comes up pretty straightforwardly. So if you have a rough ballpark of a project total cost, or maybe you know one piece of the puzzle, maybe you know how long it's going to take to program this particular project but didn't know about all the other stuff, but your records show in the past that you're pretty consistent. If programming is 30% of your cost, there's where your other costs line up. So having a bit of the information gives you a really good first cut on estimating costs. This function point process is very specific for the software industry, but I think it's worth taking a look at. And when writing software code, programmers know lots about what the code they're going to write before they even write it. They know, or usually they spec out how many inputs we're going to have, how many outputs we're going to have for a particular piece of coding, how many inquiries, how many files, how many interfaces. So given that information, and given some information about how many hours it takes to program, if the complexity was low, average, or high, that's what you're seeing those numbers there, we can come up with an estimate for how much this particular software project is going to cost. So let's take a look at the next screen. So here's an example of function point method in practice. What we've got is a software project with 15 inputs of low complexity, 5 outputs of average complexity, 10 inquiries of average complexity, and so on. And from that information, and from our information in our enterprise system that tells us what these things typically cost us to create, we can come up with a number of hours it will take to write the software code. And as a result of those hours, we can then relate that into actual costs. And so we know how long it will take and what it will cost us from at least a macro estimating standpoint.